All right, so basicsXtwin. That's what we're looking at here. All right, first one's a simple logarithm. You just have to know log is bay. Remember that? Log is bay. Remember that guy right there. So my base, my argument, and my exponent. My base shall be 4, shall be raised to the second power, and it shall equal 2x plus 5. 4 squared is 16, so 16 is twice x plus 5. We're going to subtract 16, that gives us an 11. That gives us 11 equals 2x, so x is simply 11 over 2. Should be the problem that everybody gets. Number 2 is something we haven't done in a while. It's a power over root notation. So you're supposed to express this, and it's I just don't get it. Anyways, inside of this cubic root is all of this stuff. So it's going to simply be 2x squared minus 5. And the power of that is an understood 1, if you think about all of it together. And it's raised to the 1/3. That is the equivalent. We take everything inside and we raise it to the 1/3 power. 3 is built upon that. It's to solve it using y1, y2. So in y1, you're going to put 3x squared minus 5 to the 1/5 power. And in y2, you're just going to put a 6. And I'm sorry that looks so bad. Probably too early in the morning for me. But anyways, it's just applying that and using it in the calculator. And these could be done by hand, obviously. Obviously, everything can be done by hand. Anyways, take all of 3x to the second minus a 5. And see how Milbrath-Math's typing it in? Some kids make up their own stuff. And it never works. And we'll do a zoom 6, but on this one, a zoom 6 isn't going to work. You're going to have to look both left and right. The graph, thankfully, has some symmetry. Anyways, I can see that it's probably going to hit somewhere way over to the left and somewhere way over the right. So I'm going to go to Window. I'm going to adjust my X-min to be negative 100. My X-max to be 100. I'm going to hope that's enough, and I'm going to hit the graph key, and I think it is. And now I wait. There we go. Second, trace. And these are going to have perfect symmetry, so I'm just going to find one of them. Get that little cursor close, and then you press the enter key 3 times. Negative 50.9281. Now I notice symmetry, so it's also positive 50.9281. Again, I notice symmetry. That's how it happened. 4, solve the factored polynomial. You're going to use what's called the old zero product property. So x minus 2, if we just think about covering up all of this stuff, is a 0, which means x is 2. Most of you guys are getting these, a couple of you are not. 2x minus 5 is a 0, so we add 5, 2x is 5. Divide by 2, and x is 5/2. And there's going to be 2 solutions here. 3x squared minus 27 is nothing. We add 27 to both sides. We divide by the 3. X squared is 9, and x is plus or minus 3 because there were 2 answers there. And easy peasy stuff. All right, 5. If f of c is a 0, what do you know? Okay, well, first off, this means that x is c. And because there's a 0, choice 4 is true. Now, if we shift that over, we get x minus c is 0, which means x minus c is a factor because it was equal to 0. I don't like the way that they word these in algebra classes, but we enter f evenly because we are a factor. I don't know why they say evenly. That implies like 2, 4, 6, 8. But whatever. And the last one would be the remainder. When dividing by, x minus c would be a 0 because remainders match up with that. But that's also the remainder. In addition to being a 0, that happens to be the remainder as well. 6, solve 3 natural logs, 4x minus 3 equals 9. By hand answers written in terms of E get full credit. Y1, Y2 answers expressed as decimal get half credit. I don't think you'll have a problem with this one. Play your isolation game. We always isolate. We'll have the natural log of 4x minus 3 being equal to 3. We'll put our understood E in place. So log is the base is E, it will be cubed, and that will equal 4x minus 3. Then we'll add 3 to both sides. E cubed plus 3 is 4x. And then we'll divide by 4. And there you go. Now, if that was too much for you, you can get half credit by just doing y1, y2. So in y1, I would have put 3 natural logs of 4x minus 3. And in y2, what would I have put? I would have put a 9 and a zoom 6. So I get close, second trace 5. Enter, enter, enter. And there's my decimal. They're the same thing, 5.77. So I had E cubed plus 3. And divided by 4. Same exact number. 7, we have average rate of change using a table. Now, some of you numbnuts is what I want to say. Nimwits, that's the word I was looking for. Some of you nimwits really struggle with average rate of change. There is a formula for it. Average rate of change is f of b minus f of a over b minus a, which is also the same as y2 minus y1 over x2 minus x1. It doesn't really matter which one you use, but these are your x's, all right? So 8 minus 3 in the bottom. Think of that as x1 and x2. Now, when x is 8, y is 12. They have to line up. X is 8, y is 12. When x is 3, y is 0. So 12 minus 0 is 12, 8 minus 3 is 5, 12 fifths all day long. Number 8, solve using the quadratic formula. You just sing the stupid song, x equals negative b. So opposite of negative 8 is positive 8, plus or minus square root b squared, which is negative 8 squared, off tune there, minus 4ac, all over 2a. And then we figure out what's inside. So like I know this piece is 64, okay? 4 times 5 is 20, times 2 is 40, and 64 minus 40 is 24. So x is 8 plus or minus a root of 24 all over 2 times 2, which is 4. Now, root 24 is a root of 4 times a root of 6, which is 2 root 6. So 8 plus or minus 2 root 6, both pieces over 4. Final simplification, 8 over 4 is 2. 2 over 4 is a half. There's your 2 answers. It ain't hard. 9, which of the following is equivalent to the 4th root of 256? This is obviously a choice because if you think about x to the power over the root, 256 to the 1/4. Now, if you're a simpleton, which some of you are, go to your calculator, type 256 to the 1/4, and it's going to tell you 4. Because 4 times 4 times 4 times 4 is 256. So there's one of them. Now, I happen to know that the square root of 16 is also 4. So that is definitely one of them. This guy right here, you're supposed to know these things. The cubic root of 64 is also, guess what? 4. So there you go. Those are your choices. Those 4 right there. Just going over a lot of that power over root notation on these things. Number 10, use a synthetic division to find all zeros of x cubed minus 3x squared plus 16x minus 48. Given f of 3 is a 0, and this literally says x is 3 when the output is 0. So I'm going to put a 3 here. Coefficients are 1, -3, 16, -48. And then we're going to drop, and we're going to multiply, and we're going to add, and we're going to multiply, and we're going to add, and we're going to multiply, and we're going to add, and we're going to get a 0. Remainder, constant, x squared. So x squared plus 16 must be where the remaining zeros are, okay? So 2 steps and you're done. X squared is a -16. The opposite of squaring is square rooting, so plus or minus the root of a -16, which is imaginary, plus or minus 4i, last 2 zeros. That's what synthetic division is for. Moving forward to 11, given 3 terms of the sequence, -6, -15, -24, write a rule for the sequence. So the first thing you have to do is you have to decide if it's arithmetic or geometric. So it looks to me like as I move from left to right, the difference is -9. That's pretty consistent. Now, for those of you that are arithmetically challenged, I can go to my calculator, I can do -15 minus a -6, and it'll tell me -9. And I can see if that pattern holds by moving to the third term and subtracting the second term. So this is arithmetic because you are adding or you're subtracting. So I get to use that little formula right there. The nth term is the first term, -6, plus n minus 1 times the difference of -9. And the goal here is mx plus b, make it look like a line because it is a line, -9n plus 9, don't forget the -6. And we combine like terms, we have a -9n, and -6 plus 9 is 3. Now, does what I wrote work? If I plug in a 1 in here, that's -9 plus 3, which is -6. If I plug in a 2, that's -18 plus 3, which is -15. So what I wrote works. Now, half of you are listening to this without audio. That's smart, isn't it? An arithmetic sequence is given as 5, 12, 19. Find the sum of the third through the 10th terms. Okay, cool. Well, this is the third term. You may use formulas or you may write it out. If you write it out, just show me. I'll do it both ways. So I'm going to do this first with formulas. If I want the 10th term, I have to take the first term. I have to let n be 10, and I have to know the difference. So the first term is 5, 10 minus 1 is 9, and the difference is 7. Looks like you're adding 7, isn't it? So 5 plus 63 is 68. Now, why did I do the 10th term? Because of this guy right here, the sum of n things. Now, you talk about third through 10th term, there's not 7 terms, there's 8. N is 10 minus 3, add 1 back. There's 8 things. So the sum of 8 things is 8 over 2 times the first term, which is 19, plus the last term, which is 68. Let's see, that's going to be a 4. I lost my place here. 87, I think. So what would that be? That'd be 320 plus 28, 348. Now that's if you use a formula. A lot of kids and formulas don't mix. You're like oil and water. You just don't mix. So I got 348 using a formula. Let's just do this the old-fashioned way. Let's do this the easy way. It is time-consuming for some, but for some people, what I did is extremely time-consuming. So if I add 7, the next term would be 26. And if I add 7 again, the next term would be 24. And if I add 7 again, I'd be at 41. And then 48, and then 55, and then what, 62, and then 69. Shouldn't I be at 68? Yeah, I screwed up in the very beginning, didn't I? Right there. 33, 40, 47. What am I adding 7 again? 54, 61, 68. So this was 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. And what I'm going to do is I'm just going to add all these things together. Those are the ones that I have to add. So I got a 19 plus a 20. See, I would not actually write this out. I have more of a tendency to make simple mistakes on things like that. I got 348. And again, you pick whichever way you want to do it. I'm not too concerned about it. Just get the right answer, to be honest with you. A geometric sequence is given as -3, 2, -4/3. Write both a recursive and explicit rule. So I'm going to need to know the ratio. The ratio is going to be the second over the first. All right, so if I take the second term, which is 2, and I divide it by -3, and I convert back to a fraction, God bless you, because you don't know what that is, I get -2/3. All right, now let's see if that holds. Let's take the -4/3 and divide it by 2, and if it holds, it definitely is a geometric pattern, and it is. It's -2/3. So I need to write both the recursive and the explicit rule. Your recursive form is that the nth term is the first term if n is 1, and then it's the previous term times the ratio if n is greater than 1. So when I write my recursive rule, I would be at -3 if n is 1, and I would be the previous term a sub n minus 1 times -2/3 if n is bigger than 1. All right, the explicit form says that the nth term is the first term times the ratio raised to the n minus 1. There's your first term. -3, the ratio, -2/3, exponent, n minus 1. Explicit rules are so easy to write if there's a form for them. You have to figure them out, which is something we pulled from Algebra 2 a long time ago. They're not as easy. 14 is a y1, y2, plus 2 if you can do it by hand algebraically. A geometric sequence has a first term of 5, a common ratio of a third, and the sum of n terms is as follows. How many terms were there? So let's use this thing. I know that the sum is this crazy number right here. And it must equal the first term of 5 times 1 minus, the ratio is a third, to some unknown n, and it's sitting over 1 minus a third. And I can legit y1, y2 this. I didn't do that with y'all when we did these, because I was teaching logarithms still. Now, obviously, I'll do this one by hand, too. So 3, 5, 8, but shame on you for not realizing you couldn't do it. That's what kills me about kids. Like, you just don't seem to want to connect the dots. If you have an equation, you can always use y1, y2. Always. Unless the teacher says don't. See, we got a 5, we got a parentheses. Let's introduce the fraction. You'll notice I have a tendency to wrap the ratio in a set of parentheses. Because if it was negative, the parentheses are a pretty big deal. Don't have an n key, but I have an x key. And let's assume that I don't know what 1 minus a third is. So bottom is just 1 minus a third. And then close that master set of parentheses. Enter. Zoom 6. And Zoom 6 probably not going to do it. Might, but I don't think it will. We'll all be darned. A Zoom 6? I don't know. Let's see. Second trace 5. Enter, enter, enter. Yeah, it's about telling me I didn't have enough room. Looks like it did, but there was a no sign change. So let's go out to 50 on X max. Yeah, 50 did it because you can see it crossing now. Second, trace 5. Try this again. Enter, enter, enter. 15 terms. So n is 15. Now, let's do this by hand, because why not? Because you should be able to do it by hand. So I mentioned earlier that I didn't know what 1 minus a third was. I said pretend I don't. It's 2/3. Now let's fix division through multiplication. We multiply both sides by 2/3. It'll cause a straight up cancellation there. While I'm at it, the opposite of multiplication is division, so divide by 5. All right? So let's see what this left-hand side becomes. Hopefully the calculator can leave it as a fraction. You have 2/3 times 35. No, what are you doing? 2/3. You know what? Just do it this way. Times 358.72265 divided by 4782969. And then that guy is turned around and divided by 5. I was afraid of that. The calculator couldn't keep the fraction perfect. Oh, okay, so here's what we have to do. Since I'm dividing by 5, we'll put that down there. 2 times 358.72265. 717-44530. 717-44530. The bottom is 5 times 3 times 4782969. Pretty darn, that's why they were so darn close to each other. 717-44535. Four, 5, 3, 5. And that equals this guy, 1 minus a third to the n. Interesting. We're going to subtract 1. So let's take that divided by that, take away 1. Yeah, I can't do it. That stinks. That's the problem with technology, it rounds. That is the legit problem with technology, is it rounds. And I don't see an easy way around it. What I've been doing for your stuff you do in class is I've been making them smaller because of this, because the calculator rounds. Eventually it has to round. Not much you can do about that. So anyways, let's just, we've got this, take away a 1, it's equal to that. So we divide out the negativity. I'll go back and I'll type it all in the calculator at once. So I have 6.969 times 10 to the, -8th, equal to 1/3 to the n. What I'm going to do is I'm going to ln both sides, or I'm just going to do a log. A log base 1/3 of 6.969 times 10 to the -8th is n. Now I'm going to use change of base, and I'm going to type some, it's going to have to be rounded. But I'm going to do the natural log of that guy divided by the natural log of the third. And I'm going to have to round, but it's 15. That is the issue with doing things sometimes. Rounded. Completely simplify the expression 15e to the 4th, x to the 23rd over 50e to the -7th, x to the 14th. So this one's not bad. You just have to remember this property of x to the a over x to the b is x to the a minus b. It's a really easy problem. Now 15 over 50, those are both divisible by 5. That's going to be 3/10. All right? Let's think about e to the 4th over e to the -7th. That would be e to the 4 minus the -7, which is e to the 11th. Up top, you have x to the 23 over x to the 14th. And that would be x to the 23rd minus 14, which is x to the what, 9th? Seems legit. Also up top, because the subtraction was done from the numerator. And that one's done. 16 is a completely simplified problem. Now there is no cubic root of 128. It doesn't exist. But the cubic root of 128 is the cubic root of 64 times the cubic root of 2. And the cubic root of 64 is 4. So this piece right here is going to become 4. And I'm going to leave some space, cubic roots of 2. Because now I have to think about the x's too. So I've got the cubic root of x to the 16th. Now, the long way of doing this is to think about this being the cubic root of x cubed times 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 x. Because 3, 6, 9, 12, 15, 16. Each one of those cubic roots of x cubed is an x. And there's 1, 2, 3, 4, 5. And x is x to the 5th. So there is also an x to the 5th outside and a singular x inside. Now the reality is 3 entered 16 5 times the remainder of 1. That's what I'm going to do here. 3 enters 13 4 times. 3 times 4 is 12 with a remainder of 1. There's the complete simplification of that funny looking cubic. 17, using the solve blah 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 using the graphing ability of your TI-84. You must write y1 y2 as though you're using change of base. So y1, I'm an ln guy, would be 3 at the natural log of 3x minus 6, sitting pretty over the natural log of 6, and then take away 3. y2 would be the natural log of 4x minus 9, sitting pretty over the natural log of 2. If you like logs, use logs. If you like ln's, use ln's. Those are your choices. Then it goes to its calculator and it pushes buttons. The number of kids who will miss this is just borderline ridiculous. I have asked you to do that like at least twice a week now since you got back from Christmas break. But yet it will be missed by a lot of kids. Zoom 6. It doesn't look like there's an intersection, but there is because calculators don't draw logarithms right. Logarithms look like the letter R. Second trace 5 for intersect. Just press your little button until you see the cursor show up. And then press it once or twice again. And I'm doing my enter 3 times. And there it is, 2.2643. 2.2643. All right, 2 to go. This is going to be a tough one. Identify the transformations of the graph shown using function notation. So f of x became g of x. Well, what happened? First off, it was flipped, and it was more than flipped too. And I know it's hard to see because I didn't quite give you the points here. Kind of stinks that I didn't. What would this be? That'd be 4.5, 5, 5.5. Same thing here. This would be 2.5. So we ran a half a block. If we ran 1, we went up 1. Okay, so all this is 1, and we went up 1. All right, let's go over here. Kind of the same idea here. But if I run one block, I fell 2. Ran 1. Fell 1. Okay. That's weird. I seem to remember doing a doubling in here. Wonder why it's not being shown properly. No, I didn't. All right, so here's what's happened. I have taken the original function and I have flipped it. That causes the vertical reflection. Now, what else has happened? I have shifted left. I was at 4 and I became -4. And something else has happened to this thing. Because I went from a y value. No, it's fine. I haven't shifted left 4. I went from an x value of 2 to an x value of -5. I've shifted left. Look at that. 7 units, right? Went from 2 to -5, 7 units. Now, how do I do that inside? Well, to shift left inside, I don't subtract 7, I add 7. And that'll do it. That is exactly what happened. So let me show you that on Desmos so you can have a little faith in it, because I know it seems weird. It'd be nice if you could pull out your Desmos while you're doing this. So the original function was a quadratic in vertex form. It had a vertex at 2, 4. And the original function was x minus 2 quantity squared and then plus 4. That's what it was. Now, what I'm saying has happened is I have made it negative. So I took the whole thing and I wrapped it in a set of parentheses. I need to introduce one right here. And that would put me right here. Now, what else did I say happened? I said that I added 7 inside because I had to shift it left 7. And you'll see that those line up. That was the original. This is the new. That's how it was done. I negated the whole function and I added 7 to the interior. And that's transformations. All right, the last one, find the average rate of change for f of x shown below over the interval from 0 to 4. Lots of ways of doing this. I mean, with a graph in front of you, you can go all the way back to 7th grade and you can just draw a line. Because this is where x is 4, right? And this is where x is 0. So we rose 12 units and we ran 4. There's your average rate of change. And that, boys and girls, is the basics X-Twin. I'm sorry I'm not 100% this morning, but it is what it is.